now we are going to another part of hypothesis testing, and this is a review for you. But as I said, I never take assumptions because I don't know exactly what people have covered, what they are comfortable with. So we are going to review type 1 and type 2 errors. You do recall that a type 1 error, maybe we can look at the slides and illustrate this clearly. So this big column represents the truth. Excuse me. And this big column represents the conclusions we are going to make. Now, this column of the truth is divided into two. One, which would be column 1, column 2 is assuming the null hypothesis is true. And column 3, which is assuming that the null hypothesis is false. So if the null hypothesis is true, okay, that A doesn't cause B, and we reject that null hypothesis, have we made the correct decision? No, we have not. Because the null hypothesis is true and we are rejecting it, so we've made what? An error. If the null hypothesis is true and we fail to reject it, have we made the right decision? Yes. Because it is true, we have failed to reject it, therefore we go with what is on the null. So type 1 error is the probability of rejecting the null hypothesis when the null hypothesis is true. In other words, if we go back to our example, alternative hypothesis says A causes B. The null hypothesis says A does not cause B. Now, if the real truth is A does not cause B, and we reject the null hypothesis, then you are going to end up concluding that A causes B when it is an error, because the truth is that the null hypothesis is true and we have rejected it. So type 1 error is the probability of rejecting the null hypothesis when the null hypothesis is true. Remember, the null hypothesis is the hypothesis of no effect. In other words, A and B, negative effect. A causes B, positive effect. So if we reject the null hypothesis when it is true, in epidemiology, what error do we make? If the null hypothesis is true, it means that there is an association between A and B. So when we reject it, we end up concluding that there is an association. So we make what we call a false positive. Because remember, the null hypothesis is a hypothesis of negativity and association. So if it is a true association, but we reject it and conclude there is an association, that association we are concluding there is a false positive what? Association. So a type 1 error is the probability of a false positive in epidemiology. In statistics, it is the probability of rejecting the null hypothesis when the null hypothesis is true. So we go back to the slide. And now we go to this last column. Now, assuming the truth is the null hypothesis is false, and if it is false and we reject it, have we made the correct conclusion or decision? Yes. But if it is false and we fail to reject it, then we've made a wrong decision. And so type 2 error is the probability of failing to reject the null hypothesis when the null hypothesis is what? Is false. I usually give social examples, and sometimes people don't like them, but let me give this example, two examples, one social, one judicial, as we look back to the slides, on this slide and see. Now, in Uganda, every accused person is innocent until they are proven guilty. So if somebody is arrested that he stole something or he killed somebody, the law in Uganda is that the accused is innocent. So the null hypothesis is that this person did not kill that person until the state proves that this person killed the person. Now, if the judge rejects the null hypothesis when it is true, the truth of the null hypothesis, this person did not kill, means that the accused is innocent. If the judge rejects the null hypothesis, he or she will conclude that the accused killed the person, but he would have made an error. The truth is that this person is innocent. He would have been wrongly accused as a murderer. So that will be a false accusation, a false positive. Now, assuming the truth is that this person killed, therefore the null hypothesis of innocence is false. Because in Uganda, we are presumed to be innocent until the state proves you are guilty or you are accuser. Now, assuming that presupposition of innocence is false, that means this person actually did what? Killed. And then the judge says, the judge fails to reject the null hypothesis and says the accused is innocent, when indeed the accused killed the person. Then the judge again would have made an error. He will set this person free that is innocent when in truth this person killed. So a type 2 error is a false negative. The judge will assume that this person is innocent, but it will be a false innocence. The truth is that the person killed. So a type 1 error is a false positive, while a type 2 error is a false negative. Another example I can give, if you are a soccer lover and you go back to your home at midnight or at 1 after watching Manchester United play against Chelsea or Stoke at a match which started yesterday at 11 p.m. Your wife states that you are coming from side dishing, okay? And you say, no, I am not coming from side dishing. I'm innocent. But if your wife rejects the null hypothesis of innocence and concludes, if rejects that null hypothesis and concludes that you are coming from side dishing, she will have made a type 1 error. She will accuse you falsely when in actuality you are innocent. But assuming the truth of the matter, you are coming from side dishing and you are lying that you are coming from watching a match, and she believes you when she asks you what was the score, and you tell it because you heard it on the radio and even who scored, she will assume that you are what? Innocent, when in actual case you are guilty. So she will say, my husband is faithful, when actually we cheater. So those are examples of type 1 and type 2 error. So alpha is the type 1 error. The alpha we've been talking about all along. Whether it is one-sided upper, one-sided lower, two-sided, it is the type 1 error. And it represents the probability of rejecting the null hypothesis when the null hypothesis is true. Also, alpha determines the critical value and the rejection and the non-rejection areas that we saw in the diagrams that we drew and we illustrated earlier on. It is alpha that determines the cutoff, whereby one side is rejection, one side is non-rejection. So typically in research, we want to keep alpha small, so that if we make a false positive error, the times we are making a false positive error are small, they are less. So that is our goal. And we state the alpha, in research we state the alpha early enough. You cannot first do the study and start analyzing and say, if I use this alpha, is it significant or not significant? You can't change goalposts halfway the match. The goals have got to be set before the match begins. You can't see somebody going to shoot and then you move the posts away and say, oh, but he shot outside. No. So in research, we also state the alpha before we do the study. Okay, type 2, and now I introduce something else that is now known as type 2 error and power. And we shall see what power is. Now, type 2, we've seen, is the probability of probability of failing to reject the null hypothesis when the null hypothesis is false. It is the probability of a false negative, because type 1 is the probability of a false positive. Now, if we can go to the board, type 2 error, let me say type 1 is represented by alpha. Type 2 is represented by beta. So beta, which is type 2 error, is probability of failing to reject the null when or given, this says given that the null is false. This is the type, this is the probability. So, and this represents, beta represents the false what? Negative. Now, since the probability ranges from 0 to 1, 1 minus beta is the same thing as 1 minus false negative, and this gives you true positive. If this plus this equals to 1, then 1 minus false negatives gives you the true positive. So 1 minus beta is what we refer to as the power of the study. And why? Because it represents the probability of the study to find a true positive result when indeed the result is true positive. That is the power of the study. Its ability to find a positive result when in actuality the result is positive. So 1 minus type 2 error or 1 minus beta represents the power of the study. So when we are designing studies, we want to minimize alpha, the false positive rate, and maximize power, the probability of finding a true positive when indeed the relationship is a true positive. These are a few things we've already covered, and this is showing the two type 1 and type 2 errors in a different way. But let us look at their relationship. What is the relationship between a type 1 and a type 2 error? When a type 1 error increases, then the type 2 error decreases, and vice versa. They are complementary. As you decrease your alpha, you are increasing your power. Because when you decrease the false positive rate, you are increasing the true positive rate. So they are inversely related. But there are also other factors that affect type 2 error. For example, as you can see here, when beta increases, when alpha decreases. Beta increases when the standard deviation increases. Beta increases when the sample size decreases. And please note that when beta increases, 1 minus beta, which is the power, decreases. So when you decrease alpha, you increase beta, you are decreasing power. When you increase the variance, your power decreases because your beta is increasing. When the sample size is small, your power decreases. Most of you will encounter this in research. Many people will ask you, do you have enough power given that sample size? Why? Because if the sample size is small, then the power is what? Small. And you will be encountering that most of the time. So I want to end this session by just taking a review of what we've covered. We've covered that it is first thing we do, we specify the population value of interest. Is it a mean? Is it a proportion? Is it a difference in means, or a difference in proportions? Then we formulate the null and alternative hypothesis. Then we specify alpha, the desired level of significance. And alpha automatically will give us the critical value and the rejection area, whether it is one-sided upper, one-sided lower, or two-sided. And then we now obtain the statistic from the sample, and we compare it with the Z or the T in the table, and then we conclude whether our observed Z or T lies in the rejection area, so we reject the null, or lies in the non-rejection area, so we fail to reject the null. So next time we are going to continue from examples of conducting hypothesis testing using means and using proportions. Thank you.